Hi everyone, welcome again. In this video, we will learn a little bit about cloud native apps. We will see how can we build cloud native apps using Spring Cloud Stack. Spring Cloud is basically a project under Spring umbrella, and under the Spring Cloud project, we have different components, or you can say different Spring projects. So we will cover these projects on a very high level, and we will see how can we build cloud native applications using Spring Cloud project. So let's get started and let's cover the agenda first. Although the video is about cloud native apps, but this is not an introduction of cloud native. There is so much to cover when it comes to cloud native, including cloud native patterns, architecture, different practices, implementations. So it's not possible to cover the introduction of cloud native in general in a single video. We probably need another video just for the cloud native. So this is not an introduction of cloud native, but even if you don't understand anything about cloud native, you will be able to understand the examples or the scenarios that we will discuss in this video, so no need to worry. Second, this is not a hands-on video on cloud native apps or Spring Cloud project. The reason is we already have a playlist. You can check out this playlist. You can also find the link in the description. So in this playlist, you will find the hands-on exercise videos on nearly every topic that we will cover in this video. So what is this video all about? This video is about understanding different Spring Cloud projects, how they are related, and how they can be used together to build cloud native apps. So we will start with a very general purpose microservices architecture. This is not the perfect architecture or the best solution, but this is enough to get started. And in real life, you will see variations of this architecture or of this design. The focus is on understanding the Spring Cloud projects to cover different components, to touch different components, and how can we relate those components to Spring Cloud projects. And in the end, there will be a quick tip section where we will see when to use which Spring project in general. Okay, so if you follow along by the end of this video, I'm sure you will feel confident and you should be comfortable to start with Spring Cloud umbrella. So let's kick off. So here is the scenario, but what exactly is the scenario? Well, for this exercise, we don't really care about the scenario because we don't want to focus on the problem domain or the business domain for this video. The focus is on the Spring Cloud projects and how can we work with them. So for the sake of simplicity, let's consider that the requirements are almost finalized. So we know what to do. And for this exercise, we know we are going to build a couple of microservices. These microservices will talk to each other and we need some data stores. And for this scenario, we know we need strong ACID guarantees. So we chose to use RDBMS, which is relational database like MySQL or Postgres. Now that we understand the scenario, let's move on and see how to build application based on this requirement. So we know we have to build a couple of microservices. So we start with first microservice and we know we need to use relational database like MySQL. So there is this RDBMS. It could be anything, any relational database. So the service one is talking to this relational database and we have a boundary of first microservice. So we have a microservice and this microservice has its own database, which is RDBMS database. And similarly, we have another service. This service also has its own database, which is again a relational database. And there we have the boundary of second microservices. So now we have two microservices and these services have their own database. Now in such architectures, we generally have one more component related to caching. So it could be a replicated, a distributed, but generally the cache is outside the application boundary. So we have a component just for the caching and both the microservices are interacting with this caching component. So we have one more component in this architecture. Then we want this system to be an event-driven system where the services will be loosely coupled. And to build an event-driven system, we need an event streaming platform like Kafka. And that will enable the services to send the notifications to, and the interested consumers can listen the events and can react based on those events. So we add another layer like Kafka, and both the services will send the notifications to this event streaming platform or the Kafka cluster. Now let's suppose for the service number 2, which is this one, there is a serverless function which is interested in the events. And this serverless function will listen to the events sent by the microservice 2. And based on the event, it will simply store the data to a NoSQL data store, maybe just for the tracking. So now we have a consumer of microservice 2 which is interested in the events sent by microservice 2. So this serverless function will listen to the events sent by microservice 2. And similarly for the microservice 1, we have another downstream consumer. Let's say this is a notification service. The purpose of notification service is to send the notifications. It will receive an event, it will listen to the events sent by microservice 1, and then it will shoot an email with the help of an email service. So we have another consumer of events for microservice 1. So now we have quite a few things in this picture, and the next thing we will focus on scaling the app. To scale the apps, we want to scale out and scale in. That means we should be able to add more instances of services. So let's say we add more instances of service 2 to scale service 2, and similarly we should be able to add more instances of service 1. But as soon as we add more instances to the services, we face a problem of service discovery. How to locate the services, how to find the right instance. When a client makes a call to a service, how to redirect that request to a particular instance, maybe a healthy instance. And to solve that problem, we generally use a service registry or a service discovery solution. When we place a service registry or discovery solution in the picture, that service registry works with all the applications, all the services, and it gathers the information of all the services. So it has that metadata, how many services are running in the system, how many instances of those services are functional. It also has the metadata about healthy instances. So service registry, as the name suggests, is the registry of all the applications. All right. Now that we have this service registry and we have different microservices, we need another layer of abstraction, which is the API gateway. When we have the API gateway in the picture, API gateway basically redirects the request to appropriate services. And to do that, it also talks to the service registry. So we have this communication going on between the API gateway and service registry. Why do we need API gateway? Well, an API gateway acts as a facade for the clients. The gateway basically hides the complexity of the system. The client should not bother what is the architecture behind the API gateway. There is no need to find out how many services are there. The client should make a request to the gateway, and the job of the gateway is to redirect those requests to appropriate services, to aggregate the response, and to send the response back to the client. That's it. So an API gateway simplifies this communication between the client and the system. All right. So on the left hand side, we have the client, and this client will make a call to API gateway, and the API gateway will redirect the requests to microservices, whether it is service 2 or service 1. It depends on the request. All right. And now we have an overall boundary of the system. And inside this boundary, we have many components. We have serverless function, we have NoSQL data store, we have different services, we have decentralized cache, we have service registry and API gateway. Considering everything that we have done till now, you may think that we are done, but it's not really the case. There are many things that we can include or we can do in this architecture, but for the sake of simplicity and for this discussion, we will focus on two more things. Number one is configuration management. We need to manage the configurations of the applications in a clean way. When we have an application, when we build an application, it moves from one environment to another, from local to dev to TST to UAT to production. And each environment would have a different set of configurations or properties. So properties must not be hard coded in the application if we want to scale, if we want to run applications in a cloud native manner. So we need to externalize the configurations and place them outside the application. And for that, we need another component, which is the config server. We need some kind of configuration server that acts as the centralized store of configurations for all these services. So all these applications will talk to this configuration server to read the properties. And the second thing is related to the security. How do we securely save the credentials, let's say DB username and password or other sensitive data? For that, we generally need another component, which is the secure vault. So now we have another set of boundary. You can say the common services like configuration server and the secure vault, and all the applications will use these common services, whether it is API gateway or service registry or any component basically. So more or less, this is the design, this is the architecture that we are dealing with for this video. As for the real world project, well, things vary. There are many factors that influence the design. It could be the use case, the requirement, the deployment model, the skill set. It could be anything basically. But here we are covering most of the core components that we generally need. Now that we have a very basic general purpose architecture here, let's move on and try to understand how can we implement these things using Spring Cloud project. We will now try to map these components to different Spring projects. So let's move on. So here we have another architecture diagram for the same thing, but with more details. And here we will see what Spring has to offer to implement these boxes. So let's zoom in and start with microservices first. So here we have two microservices, service 1 and service 2. How do we build microservices? We use Spring Boot. We know how to build Spring Boot APIs. To build Spring Boot based services, we generally use Spring Web and Spring Web Flux dependencies. All right. So there's nothing special. These are simple Spring Boot APIs. In the real world, they can be way more complicated. There may be multiple dependencies or libraries involved depending on the use case and the requirement. But for the sake of this discussion, since we are only focusing on Spring projects, so this is a simple Spring Boot API. All right. Coming to the databases, we have two relational databases. Service 1 is using MySQL and Service 2 is using Postgres. Now for Spring, it does not matter actually. Spring has a project, Spring Data, which is an abstraction over the actual data store. So we can use Spring Data in respective services to implement the database connectivity with the corresponding data store, MySQL or Postgres. All right. So this is the Spring Boot API and we are using Spring Data project to connect to the database. Now under Spring Data, we can use Spring Data JDBC, Spring Data JPA, plain Hibernate or anything. If you want to understand the differences, I suggest you check out this video. All right, moving on. The third component that we will be focusing on is the cache. Now, there are several options to implement a caching solution. We can use Apache Ignite, we can use Redis. Redis is one of the most popular solution to implement the caching mechanism. And in this case, let's say we chose Redis. So we can set up a Redis cluster and we can use that cluster to have a distributed cache. And how do we connect to that cache? How do we write the data and read the data from Redis cluster? Well, we can use another project, Spring project, which is Spring Data Redis, which is mentioned here. This is Spring Data Redis, and we can use this project to connect to a Redis database or Redis cluster. All right. At this point, let's quickly go to the Spring documentation and see where we can find the details of this Spring Data project. So if we go to the home page of Spring documentation where we can find the list of all projects, this is the Spring Data project, and under this project we can find the details of Spring Data JDBC, Spring Data JPA, and this is Spring Data Redis. We can use this project to implement a caching solution and we can find the details here. All right, moving on. The next stop in this chain is the event bus. Because we want to build an event-driven solution, so we need to use an event streaming platform, and we decided to use Apache Kafka. So this is that component, we named it event bus, and the underlying framework is Apache Kafka. So considering we have Spring systems, how do we connect to Apache Kafka? How do we send an event to Apache Kafka to topics, and how do we consume it? Well, we can use Spring projects like Spring for Apache Kafka or Spring Cloud Stream with Kafka Binder. And using either of these projects, any service can send the events to Apache Kafka and any service can consume the same event. Now let's go back to the documentation again to find the details of these two projects. If we scroll down here, you can find the details for Spring for Apache Kafka, and we can use this project to work with Kafka. And under the Spring Cloud, we can find Spring Cloud Stream. And this project has a concept of binders. So we can use different binders. For example, if you are working with Kafka, we will use Kafka binder. If you are working with RabbitMQ, we will use RabbitMQ binder. So we have a couple of options here to work with an event bus. And similarly, to consume the events, we can use the same project, which is Spring for Kafka or Spring Cloud Stream. Now, here in this example, the consumer is a serverless function, and this function will consume an event from the event bus, and then it is storing some data in a NoSQL database. All right. So how do we implement these two things? As for this serverless function, we have another project, which is Spring Cloud Function, which is an excellent abstraction over the cloud vendors. So using Spring Cloud function, we can create or develop serverless functions which can then easily be deployed as Azure functions or AWS Lambda or GCP functions. So this is cloud agnostic, this is vendor agnostic. And where to find the details of this Spring Cloud function? Well, under the Spring Cloud umbrella, here it is, Spring Cloud function. So you can find all the details related to this project here. As for the NoSQL data store, we have couple of options. We can use Cassandra or MongoDB or any other NoSQL data store. So in this scenario, if we are using Cassandra, we have this project Spring Data for Apache Cassandra, which is part of the Spring Data project, and we can use this project to work with Cassandra. And we'll go back to the documentation again under the Spring Data. Here you can find other projects as well. For example, Spring Data MongoDB to work with MongoDB, Spring Data for Apache Cassandra to work with Cassandra. And similarly, we have other projects to support other NoSQL data stores like Couchbase, Elasticsearch, Apache Hadoop. All right. So we can use these projects to implement different solutions based on the requirement. And coming to the second consumer, which is the event service, and this is using another downstream service basically to consume the event and maybe to trigger a notification. And these two services can be anything depending on the requirement. But for the sake of this example, let's say these are simple Spring Boot services, and it is using Spring for Apache Kafka to consume the event, and it has to call the downstream service. So we can also implement this service to service calls using Spring Cloud OpenFain, which has the ability to make synchronous calls, HTTP calls from one service to another service. So here in this example, event service is calling downstream service using Spring Cloud OpenFain. So let's go to the documentation again. And if we go to the Spring Cloud, here we can find the details of Spring Cloud OpenFain. So we can use this project to implement service to service calls. All right. So we have implemented everything here. Basically, let's move on. Coming to the service registry, we have different solutions available provided by the Spring to implement a service discovery solution. Spring Cloud Netflix Eureka is one of them. And where will we find the details? Under the Spring Cloud, if we scroll, here it is, Spring Cloud Netflix. All right. So we can use Spring Cloud Netflix to implement a service discovery solution. Then we will add the corresponding dependencies to the services which will act as service discovery client. So we have now the service registry implemented using Spring Cloud Netflix Eureka. The next step is to implement an API gateway. Again, there are different options to implement an API gateway. We can, if we want to develop the solution from scratch using Spring Cloud Stack, then we have the option to use Spring Cloud Gateway, which is another project under Spring Cloud, and you can find it here, Spring Cloud Gateway. The benefit is you have the complete control. You can develop the cloud gateway as you wish, but there are other options as well. We can use a custom made solution. We can use Nginx, for example, to implement a cloud gateway, or we can use any cloud offering, let's say API management tools from Azure. But if we just focus on the Spring Cloud umbrella, then we can use Spring Cloud Gateway to implement an API gateway. And the last two services, which is Config Server and Secure Vault. Starting with the config server, to implement a configuration server, we will use Spring Cloud Config Server. Again, to implement a config server, there are several options. We can use a cloud offering. We can use config maps, for example, if we are using Kubernetes. But if we simply want to use a Spring project, depending on the use case, we can always use Spring Cloud Config Server to implement a configuration server. And we can find the details of this project under the same Spring Cloud. Here it is, Spring Cloud Config. The last component is Secure Vault. Secure Vault is used to store the credentials or the sensitive data in a secure manner, in encrypted manner. And we have different options to implement a Secure Vault. We can use a cloud offering like Azure Key Vault. There are other options like we can use the Secure Vault from HashiCorp. And we can also create our own Secure Vault using Spring Cloud Vault depending on some other solutions. And we can find the details of Spring Cloud Vault under the Spring Cloud umbrella. So here we can find Spring Cloud Vault, and you can find the documentations and samples and everything to implement basically a Spring Cloud Vault. So here we saw the details of different Spring projects and how can we use them to implement different boxes, different features or different components in the system. And by now you should be comfortable with different Spring projects. We should be able to understand the purpose of a Spring project, when to use them, where to find the information if we have to use them. And the last step is kind of a summary of all these things, where we will see when to use which Spring project. So let's move on. So here we have the summary of everything that we have discussed till now. So we start from here. We have to build a service using Spring Cloud Stack. To build a service, we will use Spring Boot. We can use Spring Web or Webflux. To implement the database connectivity, we have to use Spring Data Project. And under Spring Data Project, we have different options like Spring Data JDBC, Data JPA, Data Redis, Apache Cassandra, Spring Data for Mongo, for Couchbase, and so on. Moving on, to implement the service registry, we can use Spring Cloud Project, and we have three options as of now. We can use Spring Cloud Netflix, we can use Spring Cloud Console, or Spring Cloud Zookeeper to implement a service discovery solution. To implement an API gateway, we can use Spring Cloud Gateway. And as for the event streaming, we can use Spring for Apache Kafka, which comes under Spring Project. And we can use Spring Cloud Stream using Kafka binders, which comes under Spring Cloud Project. For configuration management, we can use Spring Cloud Config Server, which comes under Spring Cloud, and in conjunction with Spring Cloud Bus, which basically enables the applications to refresh the property changes without any server bounds. To handle the secrets, we know we can use Spring Cloud Vault, and to implement the serverless functions, we can use Spring Cloud Function. Then there are some miscellaneous solutions like Spring Cloud Circuit Breaker to implement the circuit breakers. To implement the distributed tracing, we can use Spring Boot with Micrometer. And to implement service-to-service calls, we can use Spring Cloud OpenFain. We can also use REST template and web client and all those things. So that completes everything which we intended to cover in this video. I hope it gave you a very good information on different Spring projects, and I hope you feel comfortable enough to start on your own. And if you need any help with the implementation, you can always refer this playlist where you can find all the hands-on videos. So that's all for this video. See you in the next lecture. Thanks for watching.